Capital budgeting answers the question of where a firm should allocate its capital among various projects. There are several methods for determining the relative profitability of different projects. The first one we're going to talk about is called the payback period. This measures the amount of time it takes a project to recoup its initial cash investment. So most of the time, projects have some initial cash investment that the firm is required to make to begin the project, and then that project will start returning cash flows periodically after the project is started. And what we're asking is how long it takes for those cash flows to add up exactly to the initial investment amount. That's what the payback period is. We can either value the cash flows in the year they occur, or we can only look at their present values. Let's go through an example. So here we see project A, and it has an initial cash investment in year 0 of $100. In year 1 it returns $90, in year 2 $20, and in year 3 it returns $40. After year 1, we have $90 from the $90 cash flow that's generated in year 1. And our payback period, we're trying to find how long it takes to get the initial cash outflow, which was $100. We have 90, we only need 10 more. We can see in year 2 we get 20, but we don't need all 20, we only need 10. So if we assume that the cash comes in throughout the year, we can find how long it takes to get this 10. We just divide the 10 that we need by the cash that's actually generated in that year, and we can see it'll only take us half a year to accumulate that $10. So the payback period is the first year it took to get the 90 plus half of the second year it took to get the $10 is 1.5 years total. So it takes 1.5 years for this project to pay back its initial investment. We can also find the present value payback period, the only difference being that we evaluate each cash flow as of year 0. So the whole process is exactly the same, but instead of looking at this as a 90 and this as 20, we have to first compute their present value and then evaluate what the payback period is based on those present values. So let's find the present value of each cash flow. Well, if we assume the discount rate is 10%, first we need to find all of these present values. The negative 100 is already in year 0, that is the present, so that's the present value itself. The present value of this $90, well, it occurs in year 1, so we divide it by 1 plus the interest rate, 1.1, and we get a present value of 81.82. The $20 cash flow occurs in year 2, so we divide it by 1 plus the interest rate squared. We raise that to the second power because we're discounting that back 2 years. That gives us a present value of 16.53. And finally, 40 divided by 1 plus the interest rate raised to the third power gives us a present value of $30.05. So these are the present values of our cash flow. Now we can go through and find what the payback period is. Well, again, we're trying to find out how long it takes us to get this initial $100. After 2 years, we have $81.82 in the first year, plus $16.53 in the second year. That gives us a total of $98.35. So to get to this 100, we only need an additional $1.65. Well, we will receive this. Remember, we put how much we need, 165, divided by the total cash we're getting in the next year. The next year is the third year. We're getting 30.05. So the 1.65 over the 30.05 is only going to take us 0.055 years to get that additional $1.65. So our present value payback period is, it takes us 1 year to get 81, another year to get 16.53, and it takes 0.05 years to get the additional $1.65. Our present value payback is 2.055 years. The next thing we're going to talk about is net present value. This is the present value of a project's cash inflows minus the present value of its cash outflows. So it's the present value of the cash the project will generate after we net out its costs. That's why we call it the net present value. The easiest way to calculate net present value is to use our calculator's cash flow register. Let's find the NPV of project A if the discount rate is 10%. So here we see it's the same project that we just looked at, project A. It has the same cash flows, the same timeline. So we just want to enter in these cash flows into our cash flow register, and there's a button that says NPV that'll solve it what the NPV of this project is. So first we enter in the first cash flow, negative 100, and press CFJ for the cash flow register key. That's what we use to tell the calculator that we're entering in a series of cash flows. So we type negative 100, then press CFJ. The next cash flow is 90, so 90 CFJ. The next cash flow is 20, the next cash flow is 40. That's all the cash flows of the project. Now we have to enter in the interest rate that we're using to discount these. We're given that it's 10%, so we enter in 10 and press I/YR, interest per year. And then we press Shift NPV. That'll solve for the net present value of this series of cash flows. It gives us a net present value of $28.40. Next, we want to talk about the profitability index. This measures how profitable a project is over and above its initial investment. The formula for profitability index is the index equals the present value of the benefits of a project, the cash inflows, over the present value of its costs, its cash outflows. So, when finding the profitability index, we need to find the present value of the benefits and the present value of the costs separately. Notice that the denominator is cost, so our numbers will all be positive here. So, when we were doing net present value and we were doing the payback period, we treated the outflows as a negative number. Here, we're inputting costs. So, a cost, remember in Project A, we had an initial cost of $100. We wrote that as negative 100, but here, we're going to write it as positive 100 because it's being represented as a cost. So, a positive cost does mean a cash outflow. So, just know that this profitability index will always be a positive number. So, let's find the profitability index of Project A. Here's Project A again. We need to find the present value of the costs, and the only cost we have is the one in year 0 is already the present, so the present value of all the costs is just $100. We need to find the present value of the benefits. Well, the easiest way to do that, we can just use our cash flow register in our calculator and ignore the cash outflows, the negative $100 that occurs in year 0. So for year 0, we'll enter in the number 0 just as a placeholder. So we can enter in the 90, 20, and 40 in the right time periods. But since no benefits occur in year 0, there's no cash inflows, we're just going to put 0 into our calculator. So we press 0, then we press CFJ. Now we want to put in all of the cash inflows, because again, we're trying to find the present value of the benefits. So we press 90 CFJ, 20 CFJ, and then 40 CFJ. Now we have all of the cash inflows into our cash flow register. We want to discount them at 10%, so we enter in 10 for interest per year, and then we find the net present value. That's just an easiest way to find what the present value of all of those cash flows are, what the present value is of all those cash flows, and we find that it's 128.40. So that's the present value of the benefits of this project. So the profitability index is the present value of the benefits, 128.40, over the present value of the cost, 100. It's 1.284. That's the profitability index for Project A. The internal rate of return. This is the interest rate where the NPV of a project equals 0. So it's the rate at which the present value of the cash outflows exactly equals the present value of the cash inflows. Our calculator will also calculate this directly for us, as long as we input a project into the cash flow register. Let's find the IRR for Project A. Again, here's Project A. We want to put all of these into our cash flow register. So we have negative 100 cash flow, 90, positive 20, positive 40. And now we can just press Shift IRR. That'll give us the internal rate of return, and it's 29.36%. So again, this is the rate that gives us an NPV of 0. If we were to put 29.36% in for the interest rate for this series of cash flows and then press Shift NPV, it would be 0. That's by definition what the internal rate of return is. Finally, the modified internal rate of return. This is the interest rate that equates the present value of the cash outflows with the future value of the cash inflows. It's better than internal rate of return. Managers like this better because it assumes that any reinvestment of the project's cash flows are valued at the firm's cost of capital. This is not true when we use internal rate of return. Sometimes we can get multiple IRRs, and this is why MIRR is better. To find MIRR, step 1 is find the present value of all cash outflows at the firm's cost of capital. We'll just call that R%. Then we want to find separately the future value of all cash inflows at the firm's cost of capital, R%, and we want to find that as of the last period of the project, sometimes called the terminal value. Now, step 3 is to input the two values as the present value and the future value. So we input the present value of all cash flows as the present value. We input the future value of all cash inflows as the future value in our calculator, and then we solve for the interest rate that equates those two. That's the modified internal rate of return. That's how we find it. So let's find the modified internal rate of return for project A. Here again is project A and its cash flows. First, we need the present value of all cash outflows. The only one is in year 0, so the present value is minus 100, negative $100. To find the future value of all the cash inflows, let's first use our cash flow register to find their value in year 0, and then we can just compound the sum forward 3 years. So there's a couple of different ways that we could get to this future value. This will take the least amount of steps. It'll take 2 steps. First, we just put them all into our cash flow register, press a button to find the value, the net present value as of year 0, and then move that sum forward to the end of year 3, which would be the terminal year, the terminal period of this project. That's where we want to get all of the cash inflows evaluated as of. So we're just focusing on the cash inflows now. We're doing this separately from the cash outflows. So in year 0, there are no cash inflows. We just input 0 as a placeholder. Then 90, 20, and 40. We press 10% because we're compounding all of these forward at the firm's cost of capital, which we're assuming to be 10%. And we find the net present value, 128.40. That's as of year 0. Remember, we want it as of year 3, the terminal period of the project. So we take the net present value of 128.40, compound it forward 3 periods at 10%. So 1 plus interest raised to the 3rd power gives us the value in year 3 equal to 170.90. Now we can solve directly for the modified internal rate of return. The present value of the costs is minus 100, so that's present value. The future value of the benefits is 170.90, so we input that as the future value. The project lasts for 3 years, so we input 3 as a number of periods n. And we solve for interest. That gives us the modified internal rate of return equal to 19.56%. And that's the end of part 1.